In class yesterday, we started our first half of our section 3 notes. We started talking about the activity series and how to use it. So today we just need to finish up with that, figure out how you're supposed to be using these things. And once you check answers with this video itself, then you can go onto a worksheet so you can actually practice some more. So I wanted to do this to give you a chance to figure out whether you're doing it right or wrong. So I'm going to go through these examples on this slide. But before I go through these examples on these slides, before you watch these examples, you should try to do it yourself. If you haven't done it yourself and you're not using this video to check yourself, then you're just not going to understand what's going on. You have to try to do this yourself so you can learn how to do this correctly. So if need be, you should just pause right now. If you don't have this slide filled out because you weren't here yesterday, put in these examples, press pause and see if you can figure out the examples on the back of the notes. However you do it, make sure you understand what's going on. Because I'm not going to be here for a couple days and you're going to have to be able to figure out, using these notes, what's going on. So anyway, assuming you've already done these examples, I'm going to go through them very quickly to make sure that you can interpret this appropriately. So on this first one, it says zinc and water, right? On yours, it actually says zinc and water, and it says 50 degrees Celsius. Now, if you look at the activity series, zinc is in the same group as magnesium. And according to my example here, if I have anything in that group, I better have boiling water or this is not going to work. So if I say 50 degrees, this should be no reaction. Right? But then this next example is zinc with water and it says 100 degrees Celsius. That's the one where you actually should have a reaction. So when it said 100 degrees Celsius, you are supposed to make a product. It says zinc is in the same group as magnesium. It should make an oxide just like magnesium. This would be a zinc 2 oxide, right? Because zinc is always a +2. So this is already appropriate. I am going to displace some hydrogen and it's already balanced. So that's good for that example. The next one is tin and oxygen. Tin is in the same group as cobalt, right? And as long as I'm talking about cobalt here, cobalt is definitely higher than hydrogen on this list. So if cobalt is higher than the reaction here, reacting with oxygen, it should be able to do that reaction. So I can go ahead and make a product here. Got off there. Oh, it's not cobalt, it's the tin in with the cobalt. So tin's like cobalt. It should be able to do it like cobalt would. So I'm going to make a tin oxide, and I'm going to assume it's a tin 2 oxide because that's what I told you guys to do always. So this should already be balanced over here, but I am going to need 2 and 2 to finish it off. Otherwise, the next one, all I'm trying to determine is whether cadmium is active enough to replace lead. So you need to look at your activity series again. Cadmium is in with magnesium's group, lead is in with cobalt's group, and magnesium would definitely be able to replace cobalt, just like zinc is going to be able to replace lead. Or excuse me, cadmium is going to be able to replace lead. So this should be good. I should be able to make products. And I'm going to assume again that cadmium ends up being a +2. Nitrate plus a lead. So since cadmium is higher on the list than lead, it can replace lead. That's all you need to know. And this is already balanced appropriately. We should be fine. So then copper and hydrochloric acid. Right? That's the specific thing you need to recognize again. I'm worried about this thing being an acid. Can this reaction work or not? So in order to replace hydrogen in an acid, I have to be at least higher on that activity series than hydrogen itself, right? So I'm looking to see if copper can replace hydrogen in an acid, and copper is in the same group as hydrogen, and it's definitely below hydrogen on my activity series. So this is not going to work. No reaction. Copper is not high enough on the list. It's not higher than hydrogen. It can't displace hydrogen. The next example, will iodine replace fluorine? Because that's what I'm trying to do, is replace one nonmetal with another. Fluorine is the most active of all of our halogens, so this definitely should not work. Whereas bromine is higher on the list than iodine on your periodic table. It goes fluorine, chlorine, bromine, iodine in order, so iodine is the least reactive. This definitely would work. But I'm going to make a KBr, potassium bromide, and I'm going to kick out that iodine. I do have to balance appropriately, need a 2 and a 2, but we should be good with that. So again, hopefully checking with these things, you can understand how this activity series is used, right? You're going to have plenty more examples on a worksheet. But there are these last 3 questions that you're supposed to answer as well. Identifying the element that replaces hydrogen from acids but cannot replace tin from its compounds. Essentially, I'm just looking for something that's higher than hydrogen on the list, but lower than tin. And if you look at your list, that's not actually hard to do, right? The only thing that's lower than tin and higher than hydrogen is lead. So that has to be the answer. Otherwise, when you look through and you're looking for the most active transition metal, you are supposed to know transition metals are in the D block. So you might look at that first if that was confusing for you. But then otherwise, the most active metal that's in the D block is that manganese. So Mn would be the correct answer. And then what do precious expensive metals have in common, right? If you want to look cool, we're in a gold chain. It's a lot cooler when you don't have a green neck. So the whole idea is that there's no reaction. They're not reactive, excuse me. So they last. They don't corrode. They don't change. So they're always going to look as pretty as they did when you first got it. So precious metals are not reactive. And again, silver, platinum, gold, all precious metals. They're at the bottom of our activity series. So that's what you're supposed to know. Make sure that you complete your worksheet appropriately and always use that activity series, right? You might check with a neighbor, right, when you're done with it, but otherwise you need to do it yourself. If you don't understand how to do this because you haven't tried to do it yourself, obviously you're never going to know how to do it. Use your own brains.